All right, lesson 2.6, absolute value inequalities. If you understood pretty well compound inequalities, the lesson before, absolute value inequalities is just going to be combining that plus absolute value equations that we've learned about before. If you want a refresher on that, that's back in chapter 1. I have a video on that, I'm pretty sure. So go forth and watch that if you want a refresher. But as per usual, here is my hardest problem if you want to try it. Solve and graph. Absolute value of 1 plus 9r is greater than or equal to negative 71. So if you want to try that, go ahead, pause the video now, see if you can do it. See if you can remember and apply what you know about absolute values and how to solve those, plus inequalities. More likely than not, the answer that you get, the process that you're doing is close to how you're supposed to solve these, but not exactly, because there are some small details about solving absolute value inequalities that makes things a little bit more complicated, just a little bit. So, moving on, if we have in our student journal, page 55, we're going straight to vocabulary, straight to definitions. Absolute value inequality. An inequality that has, or that contains, an absolute value expression. Crazy how that works. An absolute value inequality is an inequality that contains an absolute value expression. It's an inequality that has an absolute value in it. Absolute deviation, we're not going to go over that. I'm going to skip right over it. But let's say, for example, I'm going to use this section up here. If we have, for example, and let's just cross this out for the sake of making sure we know it's not related. Absolute value of x, zoom in a little, is less than 2. What does that mean? That means the distance between 0 and x is less than 2. Right? Absolute value is a distance between whatever it is and 0. And here, distance between x and 0 is less than 2. If you wanted to graph that, this is what it would look like. So we have 0 here. The distance between x and 0 is less than 2. We know it can go in either direction, positive or negative, but it's less than 2. So it doesn't include 2. So open circles at 2. But it's everything in between 2. It could be 1, it could be 1.5, 1.9, 1.9999999. But it's less than 2. The distance is less than 2. If you wanted to turn that into a compound inequality, like previous lesson, we have x is greater than negative 2 and x is less than 2. Or alternatively, x is less than 2, negative 2 is less than x. If we do the other way around, absolute value of x is greater than 2, which means the distance between 0 and x is greater than 2. If we graph that one, it's almost the opposite. If we have 0 here, 2 here, negative 2, the distance is greater than 2 in either direction. If we do a compound inequality for that, we have x is less than negative 2 or x is greater than 2. Here is where there is one of the smaller minor details about doing absolute value inequalities. You might notice we have the absolute value of x, oops, that's really big, is less than the other side. That means it will be an and. If we have, let's do purple, the absolute value is greater than the other side, we have an or. And don't mistake this for meaning that if it's less than, it's always and, if it's greater than, it's always or, because it does work the other way around as well. If we have, for example, like if 2 is on this side, but it's still greater than the absolute value, that still means and. The absolute value side is less than the other side. Same thing for down here. If it was 2 is less than the absolute value side is still greater than the other side. So it's or. This is a very important distinction. If you remember those special cases from before, like if they don't overlap and it's an and, there's no real solution. If they do overlap and it's an or, that changes what your final answer is. So very important distinction. Absolute value side is less than the other side, and absolute value side is greater than the other side. It's an or. Now, for these core concepts for solving absolute value inequalities, this is where I'm not going to say things get tricky, but they do get a little bit more complicated. So I'm just going to show you examples, and those examples are going to be basically what this core concept is saying of solving absolute value inequalities, because this is just a bunch of letters and numbers. It might be a little bit confusing, but just to go over some examples. Here we have an example of absolute value of x plus 7 is less than or equal to 2. Should I do this here or should I do this in the other one? I think I'll do this. I think I'll do this here. So we have solve each inequality, graph the solution. One, absolute value of x plus 7 is less than or equal to 2. Now, first things first, I'm going to tell you this is going to be your first step. Figure out if it's an and or an or. Is an and or an or? The absolute value side is less than the other side. So if we go back up here, absolute value is less than, so it's an and. Second step, turn it into your compound inequality. Now if you remember from absolute value, you split it off into two equations. One side is what's in the bars equal to the positive, and the other equation is what's in the bars equal to the negative of what it's equal to. We're going to do a very similar thing here, where we have splitting it into two different inequalities gets rid of the absolute value bars. So we have x plus 7 is less than or equal to 2, just like it's normal. And now we have x plus 7 negative 2, but just like how the sign flips from positive to negative, the inequality sign also flips. So now it's going to be greater than or equal to negative 2. So that's another minor detail. Don't forget, even though it goes from positive to negative, the sign also flips, less than to greater than in this case. And then we just solve like normal. This is a one step, so this should be relatively fast for you. So this is our answer. X is less than or equal to negative 5, and x is greater than or equal to negative 9. If you want to combine into one statement, negative 9 over here, negative 5 over here, x is less than negative 5, negative 9 is less than or equal to x. If you want to graph it, we have negative 9 right here, negative 5 right here. Close circle at both because it's an and. Let's double check that they overlap. For negative 9, it's greater than, so it's this way. For negative 5, it's less than, so it's this way. They do overlap, so where they overlap is right in between. Third step, I almost forgot. Solve and graph. So these are going to be your main 3 steps for solving these. Let's try a second one. Absolute value of x, or of 8x, minus 11 is less than 0. Now, just like when you had absolute value equations, if it was equal to a negative number, you know there's no solution, right? Like if we had something like absolute value of x minus 8 is equal to negative 12. You know that's no solution, right? Because that implies the distance is negative. And you can't have a negative distance. You can't have a negative amount of inches. So there's no solution. Similar thing for here. If we have an absolute value is less than 0, what numbers are less than 0? Negative numbers. That means that distance has to be negative. Is that possible? No. So this one is no solution. It has to be greater than or equal to 0 in order to work. Now this doesn't mean there can't be negative numbers at all. For example, if it's greater than negative 2, that still works. There are still positive numbers greater than negative 2. It doesn't have to be only negative 1, negative 0.5. So long as it's not less than a negative number, because what numbers are less than negative numbers? More negative numbers, which means it has to be a negative, and that's not possible for a distance. Let's try a third example. This one, kind of jumping into the more complicated stuff here. 4 times the absolute value of 2x minus 5 plus 1 is greater than 21. Now, you might be thinking, okay, first step here, figure out if it's and or. We have, okay, the absolute value side's this side, it's greater than, so it's going to be an or, right? First, a little bit of a caveat. These rules only apply when it's only the absolute value on one side. Here, there's not only the absolute value on one side. We've got some more stuff there. Because what would happen, for example, if this was like, if something happened on the way where you'd have to flip this sign, then it wouldn't be greater than anymore, it'd be less than. So let's isolate the absolute value bars first. Just like how we would do normally, like if you wanted to pretend, for example, that this was an x, so now it's 4x plus 1, and we want to solve for the x. So we're going to isolate this absolute value. Same exact steps. Reverse PEMDAS, addition, subtraction first. So I'm going to be subtracting 1 from both sides. For absolute value, 2x minus 5 is greater than 20. Now when you have a number outside of absolute value bars, it's just like parentheses, where you'd be distributing. So here, we're going to distribute this 4. So you have absolute value of 8x minus 20 is greater than 20. There's another way to do this. I'll do it after I finish this way. Now from here, you can split it into 2. It's the absolute value side. Now you can figure out, is it and or? Absolute value side is greater, and greater means or. So this one's going to be an or, and now we split it into our 2 inequalities. 8x 8x minus 20 is greater than 20, or 8x minus 20 is less than negative 20. Solve like normal. These are both 2 steps. So we have x is greater than 5, or let's see what we got over here. X is less than 0. So if we graph this, 0 over here, 5 over here, let's double check they're not overlapping. If we have open circle, it's less than 0, so it's over here. Open circle, greater than 5 is over here. So there's our answer for that. The other way of doing this, the same exact way as if it was a parentheses, where you might realize, okay, 4 goes into 20 evenly. And having it on the outside is the same thing as multiplication, so I can divide both sides by 4 if I wanted to. This is where it could be important, to isolate the absolute value first, because what if this was a negative 4? If this was negative 4, then the sign would be flipping, right? So you just got to make sure you're isolating the absolute value first. So if we divide by 4, what we have over here now is absolute value of 2x minus 5 is greater than 5. Now we can split it into our 2 equations. It's greater than, so it's or. 2x minus 5 is greater than 5. 2x minus 5 is less than negative 5. Solving the same way. X is greater than 5, or x is less than 0, which is the same exact thing as over here. So, 2 different ways. As I always say with these things, this way is technically preferred because it's the safer way. Because what happens if 4 doesn't go into 20 evenly, then you're with a fraction. You have to deal with fractions now. So then this way ends up being the easier way. But if you are aware enough, you can think ahead enough, obviously this one has simpler numbers to deal with, and therefore is a little bit easier. This is also where it's extra important when it's or and, because like if this was an and, like in those special cases that I talked about last lesson, they never overlap, so it would be no solution if it was an and. Now, that's basically all the lesson part. I'm going to go through these 9 problems. This I prefer for you to do on your own, or at least try on your own. And then, so like pause the video, try these. If you're stuck on any, unpause the video, watch me go through them. But I'm going to go through these 9 right now. So, we have absolute value of y plus 2 is less than 8. The absolute value side, already alone, and it's a less than, so it's an and. So we know it's an and. Now we split it into our 2 inequalities. Y plus 2 is less than 8. Y plus 2 is greater than negative 8. Solve and graph. Y is less than 6. And y is greater than negative 10. I want to graph this. Let's put negative 10 right here, 6 right here. Let's double check that they overlap. Open circles at both. We have greater than negative 10 and we have less than 6. They do overlap. And where do they overlap? In the center right here. And this is my answer. Small little detail you might notice when we split this into ands, we know this to be true, of having these, it's the same thing as if it was written like this. This is the same thing as this. And then from there, you could still do the quick little tricks that I showed you last time of just subtracting 2 from everything. Negative 10 less than y which is less than 6. And then this answer is the same thing as this answer. But moving on to the next one. We have the absolute values only on one side, so we're good to figure out if it's and or. Here, it's greater than, so it's going to be an or. Create our compound inequality. Q over 3 is greater than 2, or Q over 3 is less than -2. Both going to be the same step. Multiplying both sides by 3 to isolate the Q. So you have Q is greater than 6, or Q is less than -6. Graph that. Let's put 6 right here, or -6 right there, 6 right there. Open circle at both. Double check if they overlap. -6 is less than, +6 is greater than. They don't overlap, so we can leave our answer right here. Now this third one looks very similar to the third example that I did earlier. Let's isolate the absolute value first. So we're going to be subtracting 10 from both sides. Absolute value 3 times 2a plus 5 is less than or equal to 27. And this is where you could have the two different ways of doing this. You could distribute the 3 across the 2a and the 5, or you can divide both sides by 27. I will just do both right now, just to show you. Let's distribute first. So this one we'd have absolute value of 6a plus 15 less than or equal to 27. Or the other way, if we divided by 3, we would have absolute value of 2a plus 5 is less than or equal to 9. And from here, the absolute value part is less than the other side, so we have ands. And then split into our compound inequality, graph and solve. Greater than or equal to -27. Over here we have 2a plus 5 less than or equal to 9, and 2a plus 5 greater than or equal to -9. Solve and graph. There isn't a ton of room to do this, but I will try my best to fit it in and graph at the same time. 27 minus 15 is 12. 27 plus 15, let's see, I have 30, 40, 2, right? Right. Divide by 6. So we have a is less than 2, and a is greater than or equal to -7. Yeah. And then the other side, or the other method, where if you just divided instead. 4 to a greater than or equal to -14. A less than or equal to 2, and a greater than or equal to -7. And we got the same answers for both. Except on this one, I dropped the equal to. This one's actually equal to. Now they're the same. If you want to graph this, it's going to be a little bit hard to do. I'm just going to shove it over here. We have -7. We have 2. Let's check where they overlap. -7 is everything greater than, so it's this way. 2 is everything less than, so it's this way. They do overlap into each other. Where do they overlap? Right in between. So there's that graph. 4, much simpler. Absolute value is already alone, so now we can figure out, is it going to be and or? It's less than, and less than is and. So I'm just going to split it off straight from here. Y minus 3 is less than 4, and y minus 3 is greater than or equal to -4. solve this pretty quickly. I'll split into 2. Y is less than or equal to 7, and y is greater than or equal to -1. So graph this, put -1 over here, 7 over here, double check they overlap. 7 is less than, so it's this way. -1 is greater than, so it's this way. They do overlap, so this is where they overlap. Same thing for this one. If you remember when I said before, I guess not up here, but back here, if it's less than 0, there's no solution. But that is the same, that only applies, same as when you figure out if it's and or, when it's only the absolute value on that side. Because we look at this one, okay, it's less than 0, so you're thinking, no solution. Not necessarily. The absolute value isn't alone yet. This is saying the distance that 3 plus r has from 0, that whole distance minus 4 is less than 0. So we don't know where that is. So let's isolate the absolute value first and then look at it. Now we have the absolute value of 3 plus r is less than 4. That is possible. There are still positive numbers that are less than 4. So now from here we can split it into our compound inequality, figure out if it's and or. Absolute value is less than. Over here it means and. So we have 3 plus r less than 4 and 3 plus r greater than -4. Quickly solve these. R is less than 1 and r is greater than -7. Graph this, -7 over here, 1 over here, double check they overlap. So at -7 it's greater than, so it's this way. At 1 it's less than, so it goes this way. They do overlap each other, and they overlap each other right in between. Now, 6. Can we figure out if it's and or from here? Yes, it's only absolute value on one side. So it's greater than, which means it's going to be or. So let's split it out. See, that one is pink, so next is green. We have f plus 12 greater than -4, or f plus 12 is less than 4. So even if it's a negative number, even though it's a negative number, there are still positive numbers greater than -4. So that's why we can still keep going. And just like before, when we're splitting it off into our compound inequality, the sign flips as well. So even though we have this staying the same, and we have this with a flipped sign and a flipped positive negative. It started negative, so now it goes positive. Solve and graph. So we have f is greater than -16, or f is less than -8. So let's see what happens when we graph this. We have -16 over here, -8 over here. We're graphing -16 first. Okay, so that's open circle. That goes this way. -8, we have open circle. That goes this way. So they both overlap each other in opposite directions. This means this one extends this way, and this one also extends this way. Because it's an or, only one of them has to be true. They don't both have to be true. So it's not just in between these two. It's where anything, either of the graphs, touch. And in this case, it touches the whole number line. This whole here at -16 is covered by the -8 graph, and this whole here at -8 is covered by the -16 graph. So what our final answer actually is, this is the graph. It's actually all real numbers. This is why it's important. Is it and or? Where are the graphs going? What are the graphs touching? For this next one, absolute value of x over 4 minus 7 is less than -2. We can figure out if it's and or. Yes, sure. But keep in mind, double checking, can there be a solution in the first place? This is less than -2. This is less than a negative number. What numbers are less than a negative number? More negative numbers. Can a distance be a negative? No. This was no solution. Last two, final stretch. So let's isolate the absolute value first and then figure out if it's and or. So sign didn't change. 4x minus 7, absolute value of that is greater than the other side. So greater than means what? Greater than means or. So if we split it off into two inequalities, we have 4x minus 7 greater than or equal to 9, or 4x minus 7 less than or equal to -9. Solve and graph. So we have x is greater than or equal to 4, r, nar, or, I keep writing it again, or 4x is less than -2. So here we have a little bit of fractions going on. 2 over 4 can simplify to 1 over 2, and that's still -1 over 2. So if we want to graph this, -1 over 2 is smaller, so -1 over 2, we'll just say that's right there. We have 4, say that's right there. Close circle at 4, close circle at -1 over 2. Let's double check if they overlap. We have greater than 4, we have less than -1/2. So we're good right there. That can stay our final answer. I haven't been boxing any of these. I always like you to box your answers because it makes it easy for me to find out where your answer is. Especially if, maybe something goes wrong along the way and you end up writing across the page, you end up writing like on the bottom of the page, you end up writing on the sides, whatever. Now this last one. Isolate the absolute value. -14. 6 times the absolute value of 3 minus k is greater than 0. It's greater than 0, so we're still good. I'm going to go... actually, no. I'm still going to do both ways. We have distributing absolute value of 18 minus 6k is greater than 0, or just dividing both sides by 6. Absolute value of 3 minus k is greater than 0. Absolute value is greater than, which means what? Means it can be an or. So we have 18 minus 6k is greater than 0, or 18 minus 6k is less than 0. Obviously 0 can't be positive or negative, so it just stays 0. Same thing for the other method. 3 minus k is greater than 0, or 3 minus k is less than 0. And we solve. -18, -18. -6k is greater than -18. -6k is less than -18. Divide by -6. Forget because you divided by a negative, inequality rule still applies, so k is now less than 3, or k is greater than 3. If we apply the same thing for over here, -3, -3, -k is greater than -3, -k is less than -3, divide by -1 on both sides to get our positive k. K is less than 3, or k is greater than 3. Same answers. So if you're wondering, okay, how do we graph this then? We only have one value here, 3. I'm going to shove that over there. So I'll make this green. So right here. No matter what, it's an open circle at 3. So we have our graph. K is greater than 3 this way. And k is, or I guess this one's greater than 3, my bad. And this one's less than 3. this way. Answer right here, or answer right here. That's it. So it covers the entire number line except for one number. It is only not equal to 3. So by now, you should now be able to do the hardest problem. So I'm gonna do that real quick. I'm gonna see if I can move this stuff down so I have more room to work with. Let's put it like right here. So our 3 steps. Is it and or? Can we figure out if it's and or? Yes. It is greater than the absolute value. The absolute value is only on one side. Or it's only the absolute value on one side. And it's greater than a negative number, so we can still solve it. It's not no solution. So when it's greater than, when the absolute value is greater than the other side, what does that mean? It means it is an or. So let's split this off. 1 plus 9r greater than or equal to negative 71, or 1 plus 9r less than or equal to positive 71. And then you just solve and graph. Greater than negative 72, 9r less than 70, divide by 9, divide by 9. I'll save you the trouble, 72. 9 does go into 72 evenly, negative 8, or 9 does not go into 70 evenly, so we're just going to leave it as 70 over 9. So we're like, oh my god, now how do we know which one goes on where? I don't know what 70 divided by 9 is. I'm going to put it to a calculator to get my decimals. Just think about it. We have our 8, which is negative. We have our 70 over 9, which is positive. We have a negative and a positive number. Negative number is always smaller than the positive number. So let's put negative 8 over here, 70 over 9 over here. Let's double check if they're going to overlap. Negative 8, close circle, everything greater than negative 8. 70 over 9, close circle, everything less than 70 over 9. They are going to overlap. Which means, what's our answer? The graph covers the entire number line, and it's all real numbers. So, there's our hardest problem. Just to sum things up, we have inequality, absolute value inequalities, an inequality that has an absolute value in it. If the absolute value side is less than the other side, the compound inequality that represents it is an and. And if the absolute value side is greater than the other side, the compound inequality that represents it is an or. This is very important. The basic steps when you have absolute value inequalities, is it and or is it or? Do you only have the absolute value on one side? If yes, you can figure out if it's and or. If not, isolate it. So then you can figure out if it's and or. Then you can figure out if it's solvable in the first place. Because if it's less than 0, or if it's less than a negative number, there's no solution. But you might have a case like we had here for number 5, where it was less than 0, but we hadn't isolated the negative, or we hadn't isolated the absolute value bars yet, which made it so it could have a solution. So, is it and or? Can it be? Can you figure that out? Is it isolated? Can it have a solution? And then once you figure out if it's and or, split it into the compound inequality that it is. One side is as if this stayed the same. The other inequality is the sign is flipped and it goes from positive to negative or negative to positive. And then you just solve and graph. So those basic 3. Those are the basic steps. Obviously for the first step, it gets a little bit more complicated. Is the absolute value isolated, and can it have a solution? Because obviously if it can't have a solution, the rest of this doesn't matter anymore. So, can it have a solution? Is the absolute value isolated? If yes, then you can figure out and or. So, Shouldn't be too bad. Just a few more nitpicky things to keep track of. And otherwise, like usual, if I have you, if you have any questions, you can ask me next time you see me, or you can email me if you have it, message me on Canvas, leave a comment, whatever. But that being said, that's the end of this lesson. I'll see you guys